Hi y'all, Robert Hefner here, the energy entrepreneur. I'm here to talk to you today about the most significant mistake I see at least small-time investors making when they're evaluating whether or not to invest in oil and gas, which as it relates to our last video, webcast number 1, minerals and royalties. What is the problem with oil and gas and why can't we seem to get it right? I'm here to explain that to you on a small scale today. So let me transition over here to the slides. This is what I call the Achilles heel of oil and gas investing. And the Achilles heel of oil and gas investing is log-normal distributions. But first, in order to understand, whoa, you came back to me. In order to understand log-normal distributions, you have to first understand normal distributions. And so bear with me. Anybody that hates math, I'm going to make it real simple for you. You will understand this after this video. For those that like math, hey, enjoy it. You're like me. So what you have here on the screen on the right-hand side is a normal distribution. The left half equals the right half. 1, 2, and 3 standard deviations left or right mean a certain probability of success. The higher point you get on this chart at the top of that little hill there, that is an increasing likelihood that you're going to achieve that outcome. So there's 3 words you need to know and understand. The first is the mode, the most likely outcome. The second is the median, meaning just nothing more than the middle number. It's a 50% chance that you arrive here. Third, and definitely not least, is the mean, which is the average of all the numbers. So in a normal distribution, the mode, the mean, and the median are all the exact same point. There are also these other things known as P90, P10. Let me explain that to you a little bit. As plotted here, on the left side, you have EP90, okay? And the reason that I am using EP instead of P is because finance bros and engineering bros can't seem to talk well to each other. So I've created this nice little term called EP90. That stands for exceedance probability of 90%. So at that line, you have a 90% chance that you're going to achieve a random distribution upon this line that you're going to sample from, that whatever the scenario might be. Again, if you go to the other side, to the right, exceedance probability at 10%. There's only a 10% chance that you're going to be to the right of that point. So finance bros, they refer to the EP90 as a P90, or maybe I'm backing this up. I can't even keep it straight. The P90 is what engineers use. P10 is finance bros, and I'm calling it EP, an exceedance probability. So the average is average with a normal distribution. So here we go. This is the problem with oil and gas investing. This is the Achilles heel for investors that don't seem to quite understand what is going on. And it's log normal distributions. So on the chart, you can already see that that line is not equal. It's not a nice little bell curve. It's lopsided to the left. So in this case, the mode, which is the most likely outcome, right, is way over here on the left. The mode is 91. And this is an actual log normal distribution for initial production rates in an area that my company, Hefner.Energy, studied in Woodward County under an operator that was called Tapstone Energy, which still exists today. So anyway, mode all the way to the left. The median, a 50% chance, is right there around 100 barrels a day. And the mean, which is the average of the data set, is over 314 barrels of oil per day. In this case, you can easily see that the mode does not equal the mean. The median does not equal the mean. Yet oil and gas companies, especially their investor relation departments, refer to the mean as if it's going to happen. As EP10 and EP90 are represented, the EP90 is all the way over here on the left, and the EP10 is way over there, close to 720 barrels of oil per day. So this is what happens if you drill one well. The investor relations department is going to say, look, our average well is 314 barrels a day over here. And that's what they're going to tell you, the investor that might not know better. But in reality, if they only drill one well, the most likely scenario is that they're going to only bring a well in that's 65 barrels of oil per day for this specific region Again, given the data that we had when we ran this scenario. Over time, as more data is sampled, the mode will converge toward the mean, okay? The mode, that little red dot, is going to move to the right toward that little pink line. If enough data is sampled, the mode can equal the mean, as we saw in the last slide with normal distributions. So this is how it plays out in real life, in the real world. The average is not average. Sorry, that wasn't supposed to come up quite yet. But if we drill 5 wells, you can notice that the mode has moved toward the mean. It still doesn't equal the mean though. 10 wells, 25 wells, 50 wells. It takes us 50 wells. Tapstone literally had to drill 50 wells in order for the mode to equal or exceed the mean. So the average well is not that average. You have to drill 50 of these suckers just to be accurate in saying that our average well is 314 barrels a day. This is the problem with oil and gas. This is the problem with anything that has a log normal distribution. The mode does not equal the mean. So the next time you hear someone say the average well in the area is 2,000 barrels a day, that should throw up a red flag to you. You know better now. I hope you all have enjoyed this very quick film, webcast, whatever we're going to call it. I'll be back again next Monday. See you then.